Hello and welcome to another eMathInstruction Common Core Algebra 1 lesson. I'm Kirk Weiler, and today we're going to be doing Unit 8, Lesson number 3, the shifted form of a parabola. This is a pretty critical lesson, and by the end of it, we're going to be able to look at particular parabolas written in particular ways and know what their turning points are. As always, you can get a worksheet and a homework for this lesson by clicking on the video's description right underneath it in YouTube. And as always, on the upper right-hand corner of the worksheet is a QR code, quick response code, that if you scan it using an app on your smartphone or your tablet, will bring you right to this video. Okay, let's get right into it though. What we're going to be looking at today is shifting parabolas. And we're really going to begin with this basic parabola y equals x squared. That's our guy sitting right there in the red. And what we're going to be doing is we're going to be shifting it. We're going to be moving it and really trying to keep track of where its turning point is. Okay? So we're going to try to figure out a way to predict from the formula where that turning point has moved. All right? Before we can do that, though, we have to review something from a previous lesson, and this is actually kind of important. Exercise 1 says without using your calculator, really important, without using your calculator, sketch each of the following parabolas on your own set of axes. So I want you to draw a little axis. Let's throw down an x, let's throw down a y. What I want you to do is in both of these cases, based on material that we did in previous lessons, you should be able to switch. I don't know what switching is. You should be able to sketch a really simple graph of both of these. Pause the video now, take a couple minutes and make these sketches, okay? All right, let's switch. Gotta invent my own terminology. Here's the key, right? We've looked extensively at graphs of parabolas that are y equals ax squared. And what we learned, right, is that generally speaking, they look a lot like y equals x squared, but if a is positive, they open upward. And if a is negative, they open downward. That's about it, right? So because here the leading coefficient is a positive 2, the parabola opens upward. Here it's negative 3, the parabola opens downward. Now, here's the important part though. If a parabola simply is y equals a times x squared, so, x squared, or negative x squared, or 5x squared, or negative 1/2 x squared, then these will all have turning points or vertices at 0, 0. Okay? It will have a turning point, also known as a vertex, at the origin. That's where its maximum or minimum will be. All right. Now what we're going to do is we're going to explore a little bit. So we're going to clear this out. Copy anything down that you need to. Okay, here we go. And now what we're going to do is we're going to take a new parabola. Okay, now on this axis, I already have y equals x squared or f of x equals x squared. And we're going to tackle a parabola that's written in kind of a weird way. X minus 2 quantity squared minus 4. Okay? And we're going to use our calculators to create a table of values, which we can then graph, okay? Now we're going to do this again and again and again in this lesson, but I'm only going to take the time this one time to go through how to generate that table of values. So I'm going to open up my calculator now, bring it up on the screen. Okay. I'm going to go into my y equals, and I'm going to very carefully put in that formula. I'll clear out anything if there's anything in here. Okay, parentheses, x minus 2, parentheses, squared, minus 4. Make sure that you're subtracting the 4 and you're subtracting the 2. No negative symbols there. Subtraction. Check over my function. It looks good. We're not going to use the calculator to graph this. We're just going to create a table of values. So let's go into our table setup. All right, now what should I set my table to start at? Well, my graph paper starts at negative 6, so it doesn't make any sense to start at anywhere sort of before that, like negative 7, negative 8. So I'm going to make my table start at negative 6, and I'll make my table go by ones. Okay, let's go into the table now. All right, now, at the beginning, there's a lot of x values that are giving me y values that I can't even fit on this graph paper. So what I'm going to do is I'm going to look for a little while, and I'm going to find the first y value that will kind of fit on comfortably. And where is that? It looks like it's right here. -1 and 5. -1 and 5 will fit on. So what I'm going to do now is I'm going to construct a little table of values, really, really tiny. I'm going to write it right in here. I'm going to just take these values right off my calculator. So x is -1, y is 5, x is 0, y is 0. That's a nice point, 0, 0. 1, -3, 2, -4, 3, -3, 4, 0, 5, 5. And there's my table of values. And now I'm going to plot them. -1, 1, 2, 3, 4, 5. 0, 0, 1, -3, 2, -4, 3, -3, 4, 0, and 5, 5. Now I'm going to attempt to draw a parabola through these points. It's easy for me to plot on this program. It's not as easy for me to draw a really great curve. So you'll have to excuse my poor graphing ability on the tablet. But, you know, it's okay, I guess. Let me grade myself. -2 points for neatness. All right, so let's take a look at exercise letter B. Get rid of the calculator. It's out of here. All right, how would you need to shift f of x to get to the graph of g of x? We're going to see this terminology, shifting. Shifting just means to take something and move it left or right, up or down, or a combination, right? So if I take this parabola and I want to move it so it lies on top of this one, don't be fooled that this one is somehow bigger than that one. That's just because we didn't graph all of this. Well, how would I have to shift it? And I think that the easiest thing to do is to simply keep track of the turning point. So if I took this turning point and I moved it down to this one, what would I have to do? I'd have to move it to the right 2, and I'd have to move it down 4. So there's my shift. Right 2, down 4. All right. Now letter C asks an interesting question. It says, what is the turning point of G? Well, that's not a very interesting question. That's at 2, -4, right? 2, -4. Then it says, where do you see the turning point in the function's equation? I'm going to write down the function's equation. I'm not going to write it down as g of x. I'm just going to write it down as x minus 2 squared minus 4. Well, the -4, that is as blatant as you get. There it is. The 2, that's a little bit weird because it's there, but it's being subtracted. We're going to explore that a little bit more, all right? But the first thing that we're going to do is make sure we understand this part, all right? So I am going to scrub out the text. You copy down anything you need to, and then we're going to move on. Okay, here we go. Look at that. Isn't that cool? I love it. Let's take a look at it one more time. So what I'm showing you is that real shifting. Watch. When I just superimpose a red parabola on top of that, it got moved 2 to the right and 4 down. It's kind of neat, isn't it? Kind of neat. Okay, let's move on to the next page. Now what we want to do is we want to explore two things. A vertical shift and a horizontal shift. Okay, so yet again, what I've got is y equals x squared already graphed. And what we're going to do is graph y equals x squared plus 2 and y equals x squared minus 4. Now, what I'd like you to do is I'd like you to pause the video and take some time, maybe upwards of 5 minutes, to create tables on your calculator to graph both of these two functions. And then I'm going to graph them, but pretty quickly, okay? So pause the video now and go ahead and do that. Okay, let's go through them. We'll start by graphing y equals x squared plus 2. All right, in terms of the graph, if I were to plot its values, and granted I've been plotting parabolas for a long time, so I don't need much of a table of values. At least not for really simple ones. But here's our y equals x squared plus 2. Remember, you want to kind of pay attention to see if you can figure out that whole 2 piece, right? Then x squared minus 4 would look like this. We could plot some additional points up higher, but we don't really need to. So this is going to be our x squared minus 4. I'll put that y here. So what was the effect? We've got y equals x squared, right? The simplest parabola out there. And then we added 2 to it, right? And we subtracted 4 from it, right? So what effect did that have? Well, when we added 2, it shifted it up 2, right? And when we subtracted 4 from it, it shifted down 4. Letter C, write down the turning points of both of these things in coordinate form, okay? All right, let's take a look, right? Easy enough. This thing had a turning point at 0, 2. This one had a turning point at 0, negative 4. That made sense, right? I mean, our original parabola, y equals x squared, well, it just had a turning point at 0, 0. Then when we added 2 and lifted it up 2 units, well, then it was 0, 2. Right? The x-coordinate didn't change. Those parabolas just stayed right on that y-axis. So letter D, what would the coordinates of the turning point of the parabola y equals x squared minus 150 be? Did you get it? 0, negative 150, right? What would this parabola look like? It would be shifted down 150 units from where y equals x squared starts, right? It would be way down there at a negative 150. All right? We're going to clear out the text. Here it goes. All right, so if we take y equals x squared and we simply add a constant, it'll shift the parabola up and the turning point with it. Subtract a constant, shift that parabola down, and the turning point along with it. Let's take a look, right? Here's that red parabola again. Let's shift it up 2 units to get ourselves y equals x squared plus 2. How about a green parabola? Blue parabola. Shift it down 4 units, right, to get that one. It's really kind of cool. They're the same parabolas, they're just shifted up 2 or down 4. Okay, one more time. So now we've got the parabola y equals x squared plus 3, or x plus 3 quantity squared, and the parabola x minus 1 quantity squared. So now, before we actually graph these, I really want you to understand. We're taking that input x, and we're adding 3 to it before we ever square. Likewise, we're taking x, we're subtracting 1 before we ever square. So here what we're going to see is something horizontally going on. Again, I'd like you to pause the video, use your calculators to create tables of values, and plot those 2 parabolas. All right, let's go through them. X plus 3 squared first. All right, our table of values would have given us this parabola. Nice miss. So that's y equals x plus 3 squared. And x minus 1 squared would have given us this parabola. It's a little better. So take a look at that. We added 3 to x, and it shifted it to the left by 3. We added 3 to x, and it shifted it left 1, 2, 3. We subtracted 1 from x, and it shifted it to the right. So it's very odd. It's counterintuitive. Adding to x shifts left. Weird. And subtracting from x shifts right. To me, the vertical transformation makes all the sense in the world. When we add or subtract, we shift up for adding, we shift down for subtracting. But the horizontal, and the horizontal will always occur to x before anything else does. When we add, we actually shift to the left. And when we subtract, we shift to the right. So, take a look. What are the turning points of these two parabolas? Why don't you go ahead and write them down. Pause the video for a second. Okay, let's do it. This thing has a turning point at -3, 0. It's so tempting to say +3, but This one has a turning point at 1, 0. Again, that negative is weird. Okay? Again, it's this cool effect, right? Where we take our parabola in red, add 3 to it, and it shifts to the left. That's a little bit of a better parabola. On the other hand, we could take a parabola, subtract 1 from it, and it shifts to the right. Let's clear out the text so you can see those two a little bit better. Kind of cool, huh? All right, one last problem, okay? Now what we want to do is we want to put the two together. So it says determine the coordinates of the turning points of each of the following quadratics. Note that the value of a is irrelevant. Maybe we'll talk a little bit about that. Let's do it right now. The reason that a is irrelevant is that when I have y equals ax squared, it's got a turning point at 0, 0, no matter what a is. No matter what a is, right? So if all I'm doing is keeping track of the turning point, that's easy enough. So when we look at this, think about it. Right, by taking x and subtracting 8, we must have moved to the right 8. By adding 5, we must have moved up 5. So that point 0, 0 must have went to the point 8, 5. And that is our new turning point. Isn't that cool? It's really kind of neat. So you take your parabola, right? You shift it 8 units to the right. You shift it 5 units up, and we now have a turning point at 8, 5. Okay? This one again, the 5 out front, no big deal, because this parabola, y equals 5x squared, would also have a turning point at 0, 0. So now we've moved it to the left 1 unit, and we've moved it down 4 units, so our turning point is now at -1, -4. Right? Isn't that cool? Likewise, this thing, y equals -2x squared, this one would also have a turning point at 0, 0, but now we've moved it 3 units to the right, 10 units down, so it's got a turning point at 3, -10. Is that neat? I love it. It's very, very easy. When you have a parabola or a quadratic function written in this form, then seeing the vertex or the turning point is very easy. That's why we call it the vertex form or the turning point form of a quadratic. Okay, I'm going to clear out all this text. Let's take a look at the last two parabolas. There's 5 times x, there's 5x squared. And there we have it shifted. There's our -2x squared. Let's shift it to the right. Ooh, and shift it way down there. All right. It really doesn't matter what the leading coefficient is. You can always identify that turning point. Okay. That was our first exposure to the vertex form of a parabola, the shifted form of a parabola, a way that you can look at a parabola and figure out the turning point by just that form. Of course, it begs a lot of questions. What happens if it's in standard form? What happens if the quadratic's written as 5x squared plus 2x minus 3, right? It's not written in the right form. We'll be getting to that eventually. But for now, thank you for joining me. As always, this has been an eMathInstruction Common Core Algebra 1 lesson. I'm Kirk Weiler, and until next time, keep thinking and keep solving problems.